Welcome back to AlgoJS. Today's question is LeetCode 1167, minimum cost to connect sticks. So you have some number of sticks with positive integer lengths. These lengths are given as an array sticks, where sticks I is the length of the ith stick. You can connect any two sticks of length x and y into one stick by paying a cost of x plus y. You must connect all the sticks until there is only one stick remaining. Return the minimum cost of connecting all the given sticks into one stick in this way. So in example 1, we have 2, 4, and 3, and the output is 14. So what we do to begin with is connect the two smallest sticks, which is going to be 2 plus 3, which equals 5. Then we add 5 back into this sticks array whilst excluding 2 and 3. So you're going to have 4 and 5. So down here we have 5 and 4. We remove those two, and then we add those two up and add the resultant back into the array. And from this process, we've gained 5 and 9 as the cost at each step. So we add those together to give us 14. So our solution today is going to be using a greedy approach. And in order to accomplish this, we are going to be using a min heap. Now a min heap is just a binary tree, a complete binary tree where the root node is less than all of the other nodes. Well, let's start out by creating a min heap from this input array. So we have 2, fill it from left to right, 4 and 3. The root is less than both its left and right child. So we have a min heap. The size of the heap at this point is 3. We're going to need a variable to calculate our total and to keep track of it. So we can set that at 0. And like we did in the example, we need to remove the two smallest values and add those up. And we're going to do this iteratively to give us our greedy solution. In order to remove from the min heap, we flip the minimum value with the bottommost right value. So 2 goes here, 3 goes here. We can now remove 2. So we have 2. We also need to remove 3. So we do the exact same. So we flip 3 and the bottommost right value, in this case it's 4. And then we remove 3. We have 2 and 3. And remember, the cost of removing these elements is going to be the summation of them. So we can add those together, which is going to give us 5. We can update the total here to 5. And we can add 5 back into the min heap. So if we add it back into the min heap, we are going to have 4 and 5. So this is what our min heap looks like now. We have a size of 2. And now we need to remove 2 of the smallest values. So we flip the values. We remove 4. So 4, 5 is on its own. So we can just remove that. Then we add these two together, which is equal to 9. We can update the total by adding 9 and 5 together, which is equal to 14. And then we add 9 back into the min heap. Now size is equal to 1. And size equaling to 1 is going to be our break clause here. So as soon as our heap size is equal to 1, we can break out of this and we can return our total, which is equal to 14. Time complexity of the solution is going to be O n log n. In order to create the min heap, it will take n log n operations, and then removing from the heap the minimum value and adding back onto the heap is going to be log n operations. So we take the largest of the two, and then space is going to be O of n, where we store n values within our min heap. Now, unlike most languages, JavaScript doesn't have a built-in heap API, so we're going to have to use the priority queue, which is provided by LeetCode. So if we initialize heap, and I'm going to be using heap interchangeably with priority queue, even though they're not the same thing. A heap is a data structure, whereas a priority queue is an abstract data type. So just bear that in mind. Now we'll initialize the heap to a new min priority queue. Total is going to be equal to 0. And then we need to populate this priority queue or this heap with the sticks. And this is what's going to take O n log n time complexity. While heap size is greater than 1, we're going to get the difference. So the difference between the two is going to be heap, and we need to get the minimum value from the heap, which is going to be the top element. So we can use dq.element with this min priority queue, and then we need to add the second value, which we're going to remove. So we've removed the first value from the min heap, which is going to be the minimum value, and then the second value from the min heap, which is going to be the second minimum value. Update total with that difference. So we add it on to total, and then we need to add back to the heap that difference. And that is it. We can just return total and give this a run. Submit it. And there you go.